Hello, I'm Michael Yada. I am in Mr. Stewart's 9 a.m. Fundamentals of Physics class, and today I'm going to be demonstrating air resistance and Newton's three laws of motion. With me, I have a bowl of wiffle balls to demonstrate the three laws of motions, and I have a book along with a sheet of paper to demonstrate gravity and air resistance. So, now that I'm all set, let's get started. To begin, I'm going to demonstrate air resistance using this sheet of paper and this book. Now, due to size and air resistance and the density of both of these, even though they're the exact same shape, they won't fall at the same rate. Observe. The reason the sheet of paper doesn't fall at the exact same rate as the textbook, despite both being square in shape, is due to how thin this sheet of paper is. It's so thin that air pressure and air resistance gets trapped beneath it as it falls, thus delaying its drop. However, if I'm to place the piece of paper onto the textbook, watch what happens. They both fall at the exact same time. That's because for the piece of paper on top of the book, as it falls, there's very little air resistance to keep the paper from falling. In conclusion, from the first experiment, I demonstrated that gravity pulls all things down at the same speed. It is air resistance that causes them to fall at different rates. When the paper and the book were on top of each other, they fell at the exact same speed because there was no resistance to keep the paper aloft. With that said, let's move on to Newton's three laws of motion. The first law of motion is the law of inertia. That states that if an object is at rest, it will stay at rest unless the force outside acts upon it. That said, let's take these two wiffle balls and demonstrate. There it is, at rest. No force acting upon it, so therefore it won't move. However, when this wiffle ball hit the other wiffle ball, it was forced it to move. An object stays at rest unless an outside force acts upon it, as I said earlier. The energy from this ball was transferred into this ball. The momentum from this ball, the force that it was traveling at, collided with this ball, and thus forced it to move since it was not nailed to the ground. Isaac Newton's second law of motion is the law of acceleration. A force acting upon an object is equal to the force pushing on it. If I were to flick this wiffle ball in that direction, the force upon this, the acceleration on this would be equal to the force I exert on it. Granted, there would be some friction to counter it, but if it were constantly applied, and without friction, it would keep going on forever. Let me demonstrate acceleration on this wiffle ball. The amount of force I exert on this object compared to the mass created acceleration. Newton's final law of physics is that of equal and opposite reactions. That is, for every action, there's an equal and opposite reaction on an object. So let's say I were to throw these two wiffle balls at each other. They would both collide and exert the same amount of force, but in an opposite direction. Let's observe. With the second experiment, I demonstrated the laws of inertia, acceleration, and equal and opposite forces. With the wiffle balls colliding into each other in the first example, the law of inertia, I demonstrated that objects at rest will always stay at rest unless acted upon by another object. With the second example, I demonstrated that force exerted on an object gives it acceleration that is equal to the force given to it. With the third example, I demonstrated that with every action, say two balls colliding with each other, there's an equal and opposite reaction.